So now this question says, given that sine 40 cos 22 plus cos 40 sine 22 is equals to k. Determine without the use of the calculator the value of the following in terms of k. Okay, so the first question here says sine 62. We need to find sine 62. Now looking back at our question, we understand that this here is a compound identity. I understand it's a compound identity because this represents A, this represents B, this represents A, this represents B. So it's the sine compound identity where if this is a plus, this here would be sine A plus B. If that's the case, our question over here can be written as sine 40 plus 22. And as you know, sine 40 plus 22 gives you 62. And this whole thing, if this whole thing is k, it means that sine 62 is actually equals to k. Now the next question wants us to find tan 118. With this question, the best approach is reduction formula. So we're going to reduce this. Since this is in the second quadrant, it can be written as tan. And tan in the second quadrant is negative. So this here can also be written as negative tan 62. So now we need to figure out what tan 62 is. From trig ratios, tan theta is y over x. Now if we want to figure out what tan 62 is, we could also figure out also y over x. But the problem is we have y, but we do not have x. Now how we do have y is this. Now sine 62 is the same thing as k, which can also be written as k over 1, which makes ky and r 1. So we need to figure out what x is. To find x, what we can do is that we can say r squared is equals to x squared plus y squared. Now substituting the values of k and 1 into this Pythagoras, we can get 1 squared is equals to x squared plus k squared. And in so doing, x is equals to the square root of 1 minus k squared. Now that you have y, which is k, and we just figure out what x is, which is the root of 1 minus k squared. With this, we can now say what tan 62 is, because it's also going to give us y over x, right? So in that case here, it will be k over the root of 1 minus k squared. And that will be your answer. Question 3 says sine 14 cos 14. And this looks very similar to double angle identities. Now, double angle identities for sine looks like this, where you have 2 sine A cos A. Yeah, this is sine 2A. Yeah, but the difference here is that we do not have that 2 before it. But we can actually put this 2 so that we can tap into this double angle identity. But now for us to do that, we have to balance it out by multiplying a half so that the half cancels the 2. So this here can be written as half times 2 sine 14 cos 14. Now this is a sine double angle identity. Now this here would give you sine 28. And since we need cos 62, now sine 28 can be changed into cos 62 due to co-ratios, right? So this here can be written as sine 90 minus 62, right? Because 90 minus 62 is 28. And sine 90 minus 62, due to cofactors, is cos 62. And cos 62 we got in the previous question to be equals to k. So your answer is just half k. And that's it.